So research on the prevention and intervention in dementia has recently been focusing on a non-pharmacological intervention, because pharma giants, they stepped out of dementia drug research, like Pfizer in 2018. And the research is now focused on the impact of the risk factors, which are, for example, lack of physical, social, or cognitive stimulation, lack of sleep, bad nutrition. And as you can see in a well-known already diagram by Livingston and others, fetched from the well-known article Lancet, there are new risk factors like air pollution quantified, early risk factors like hypertension, alcohol, obesity, and so on and so forth. The focus is now on multimodal, multi-domain intervention, as it has been published by Ngando and others in 2015, describing the FINGER study, which has been an integrated intervention, including cognitive training, CCT, physical exercises, dietary recommendation, vascular monitoring, while whereas unimodal intervention has not been proven to be statistically significant in its effect, but multimodal intervention, yes. So the approach that is followed in Austria is called MAS training, MAS for Morbus Alzheimer's syndrome, and has been started, initiated, and implemented and is performed by Professor Stephanie Auer from the MAS Alzheimer Hilfe, following major aspects of the research of Reisberg and others from New York University. And this program, performed by caregivers in the home of the person still living, a person with dementia still living there, is based on 5 columns like holistic cognitive activation, facilitation of perception, physical activity, activities of daily living, and gaming and creativity. Basically, pushing up global stimulation to activate and nurture the existing multimodal resources. And basically in Austria, it is under prescription. So how is the holistic concept brought up by this multimodal intervention implemented actually in computer technologies? The focus is basically on cognitive training. As you can see in the table to the right, which has been proposed by Häusl and Schüssler from Medical University of Graz, about recent implementation of CCT training. They are focused basically on one domain, like cognitive or physical intervention, but not integrating a whole spectrum of different multimodal intervention opportunities. And as we see on the market, Lumosity, Cognet, Cognifit, and so on, they're focusing on the cognitive stimulation. They're playful. They're also focusing on persons with dementia, like Emotiva, Onto Dementia, NeuroRacer, C-Hero, the app that has been downloaded 100,000 times. And there are European projects like in the AAL track, Rosetta, Game Up, Carebox, and so on. And they're monitoring and estimating the status of mental processes, the motivation of the user for cognitive and physical activities. But the focus on the serious game is particularly stressed in a review by McCallum and others, and emphasizing that assessment games are still highly underrepresented. And there's also recent work by Adams and others stressing the importance of telerehabilitation, particularly now under the pandemic's impact, because people are isolated at home and there's no access of caregivers face-to-face. So you need this kind of technology to keep up your exercises, your training, your stimulation. What we are using is the Digital Life app for multimodal activation of cognitive performance. That can be done at home. You can see there's a standard tablet PC in a blue coverage, which makes the whole technology robust against falling to the ground or other impacts. There's a stick, as you can see, that is appropriate for elderly, easily to use. And there's a demo version of the app that you can download on the Google Play Store. And it includes basically components for cognitive exercises, different types, also for sensomotor exercises. There is a research prototype for gaze control-based exercises. And of course, in the context of the MAS training, there is support assistance in the activities of daily living, They also organize narrative cafes, and there's a support for health services, like in the context of dietary recommendations or motivating for mobility. So basically, there's a single user, as you can see to the left mode. People are introduced. It takes maybe 1 month for digitally native elderly people, of course, to be able to use it, and then they're very proud, they're very happy. To the right, you see group-based gaming, and this is particularly very stimulating, very motivating, and it's implemented as a board game. So if persons step on a particular field, then they have to do something together with the others, and it's basically for fun in the group. There's a huge diversity of playful exercises, as you can see to the left. Standard games like Spot the Difference, pairs game, multiple choice quiz. To the right, you can see sensomotoric exercises, lifestyle questionnaire, and the puzzle. And it's particularly important to have a playful training, because serious games, they support the adherence to the training. And this more, since there was a recent article by Coley and others, emphasizing that in the finger study, CCT training was not followed so much by the person with dementia. Only around 24% under particular criteria followed that, while physical training was accepted much more, and also people with the dietary consultation. If you take the same criteria and apply it to the app that I described, that has been implemented in a study in a European project called PLAYTIME, comparable, you come up to 70% of usage. And that's maybe because there's a diversity of playful training. There are 44 topics. Each topic consists of up to 47 exercises. There are 16 types of exercises, 4 grades of difficulty. You can switch between different levels of difficulty. And in total, there are more than 6,000 exercises available in 5 languages.
Wir sehen hier den Einstieg in das Demenztraining Digital Life, und zwar die Übersicht über verschiedene Themen. Wir steigen jetzt direkt in ein Thema ein, zum Beispiel Herbst, und spielen eine Koordinationsübung vor.
Die Füße sind schulterbreit mit der ganzen Sohle am Boden.
Die Videos dazu wurden von geriatrischen Expertinnen erstellt und dienen durch die physischen Koordinationsübungen dazu, den kognitiven Zustand über längere Zeit zu verbessern. Es gibt verschiedene Bewegungsübungen. Wir gehen jetzt weiter zu einer kognitiven Übung. Es gibt zum Beispiel Multiple Choice, Auswahl in verschiedenster Form. Auch immer mit Feedback. Des Weiteren Puzzle in verschiedenen Schwierigkeitsstufen, hier in einer eher geringeren Schwierigkeitsstufe, was aber absolut adäquat ist für Demenzbetroffene. Das ist eine Übung, die das Kurzzeitgedächtnis trainieren soll. Das ist auch bei Kindern bekannt, aber hier speziell geeignet für Demenzbetroffene. Dann gibt es Lückentexte zu füllen in verschiedenster Form, was dem gesamten Kontextverständnis wieder zugutekommt. Hier ist eine Reihenfolge, eine sinnvolle Reihenfolge zu bilden. Ja, man sieht, dass es nicht ganz so einfach ist immer. Dann gibt es natürlich auch rein logisch-mathematische Übungen, die auch teilweise recht gut ankommen, verschiedene Schwierigkeitsstufen. Und man sieht hier, dass auch akustische Wahrnehmung unterstützt wird. Das eignet sich natürlich zum Mitsingen und ist sehr beliebt bei den älteren Teilnehmerinnen. Ja, in weiterer Folge sehen wir hier noch ein Memory-Spiel, eben auch für die Förderung des Kurzzeitgedächtnisses. Und dann kommen wir wieder zurück zur Übersicht und zeigen, wie der Lifestyle-Fragebogen ausgefüllt wird. Und zwar geht es hier um sogenannte Risikofaktoren, die sozusagen in der Prävention zu beachten sind, damit sich möglichst kein Demenzform entwickeln kann. Auf der anderen Seite, wenn schon Demenz festgestellt wurde, sind diese Faktoren natürlich zu beachten, damit die Krankheit nicht noch intensiver und verschlimmert wird. Hier sieht man zum Beispiel, wie weit wird abgefragt, wie weit die geistige Aktivierung.
And there's also a research prototype called MIRA for Mobile Instrumental Review of Attention. And this is basically a gaze-based interface with a serious game. And it actually exhibits gaze analysis in reference to the visual content of the serious game on the display. It's implemented with a tablet camera-based gaze tracker. It's not so precise as previous kind of external technologies that are attached to the tablet or to a PC, but it's sufficiently precise to track basic experience, reaction, and interaction with the visual content. And it has been evaluated in a study with 15 participants in a 10 weeks intervention. The adherence was 40%. And you see now in the following a video that shows in more detail how that really worked.
Lena is living in a nursing home. She is a person diagnosed with Alzheimer, a disease without a cure. Serious games for multimodal training and brain fitness. Support to delay cognitive decline. Lena is playing the MIRA game. She started to play it with the help of an Alzheimer trainer who was visiting her every week. But finally, she can play the game totally on her own, and she is proud of it. MIRA is a game to train executive functions through a gaze interface. MIRA is played on a tablet PC. The first step is to calibrate eye gaze with respect to the tablet-based display by gazing at flowers and confirming by pen. A device-embedded camera tracks the face for eye detection and the estimation of gaze orientation. After calibration, the game menu appears. Games are inspired by activities of daily living, like feeding a cat, gardening, or cleaning. The tablet camera tracks the elderly eye movements, controlling the game by gaze only. Lena has her eyes shut quite a lot, but the gaze tracker works quite well. Alzheimer's impacts inhibitory functionality of eye movements. Prosaccades fixate the stimulus, and antisaccades gaze away from the stimulus. Antisaccade tests are used to estimate the mental state. Martin shows us how to calibrate. His head and eyes are tracked. One has to fixate flowers. The red dot depicts the system's estimate of gaze on display. Within two areas of interest, the doors, the antisaccade test will be evaluated. A good or bad character might appear, and by fixating them, characters get activated, either for good or bad. The bad guy will steal food from poor cat's feeding dish. The good grandmother will provide food to the cat, to make her healthy and happy. Lena is activating the grandmother for feeding, and gets points for the overall score. Images at the bottom show different states of cat happiness. Activation of a good character provides food, and makes the cat even more happier. The images shows the progress of the game, and keeps users motivated to perform well. Lena receives a score of 1.5 out of 5 stars. Lena always wants more stars. The score is logged to the server for each game. Here is the horizontal amplitude of gaze over time. The appearances of good characters in blue should be gazed. Bad characters marked in red should be avoided. Correct gaze behavior provides a gain of points. MIRA stands for Mobile Instrumental Review of Attention. 15 participants in a field trial played it. The mean game score correlates very well with several important dementia rating scales, such as the Montreal Cognitive Assessment or MoCA, and even with activities of daily living. A second-order polynomial regression provides accurate estimates of cognitive assessments. The mean estimation error is about 2.6 points. Finally, Lena had a lot of fun playing the game.
Let's now have a look on the neuropsychological profile of dementia as it has been investigated by Mesolam and also Weintraub and others in 2015. Look at the diagram to the right. At the bottom, you see neuropathological tissue diagnosis like Alzheimer's disease, which is associated with, of course, amnestic dementia, clinical dementia profile, and in turn associated with a deficit or impact on the large-scale neuroanatomical network like the medial temporal limbic. And you can see with different types of highly related dementia types like Alzheimer's, the frontotemporal and the cortical lewy body disease, you can see that are different kind of weighting on the impacts on different kind of clinical dementia profiles and different impacts highly related on the large-scale neuroanatomical network. So what you can see is there's an impact on the disease on distinctive networks associated with the cognitive domain. So with different diseases related to the networks, and basically if we look on the time domain for the early stages of dementia, as they have visualized it in the diagrams, look to the top to the right. In the early stage of dementia, there's more differentiation between the domains. Some of them are unimpaired or mildly impaired, versus others are distinctly abnormal. So that means there's a kind of very specific profile, not only for the specific dementia disease, but also probably for the individual setting. In progress dementia, the symptom domain boundaries become blurred. You see it with the light bars and towards a uniformly affected function. And the open question, or the question for investigation, is whether the individual settings of the early neuropsychological profile can be extracted and reflected. And the approach in the PLAYTIME project was to investigate, as you can see to the left, different kind of exercise types like the puzzle, the box finder, math games, pairs games, and so on and so forth, and how they relate to specific functional impairments or capacities related to the MOCA subscores, like the visual spatial executive or attention or abstraction capacity. And psychological experts have matched this kind of exercise types with capabilities in different kind of functional domains. And for example, for the puzzle, they have identified the attention domain is highly relevant, and so on and so forth. And in a small study, so as a first step in the direction of finding out more about the diversity in the cognitive assessment and in the impairment, 8 participants have been investigated in a 10 weeks intervention with weekly MIS trainer visits and quite high adherence to the gameplay. And basically there was an overall play score, the digital score, that was highly correlated with the MOCA, but also specific game scores indicated a specific neuropsychological performance, the performance of this specific functional capability. So for example, as you can see to the left down, the difference puzzle, for example, was the score of playing that was highly correlated with the visual spatial executive. Or as you can see, the abstraction capability was highly correlated with another category called outsider play, and to the right, orientation highly correlated to box finder. So if you play the game, you get a score, and this score is highly correlated and tells you about the functional impairment in the end. In this sense, there's a coverage of neuropsychological profile based on the application of the digital Life app, but also the Myra app. And you can see down there in the table to the left, the different kind of subscores of the MOCA assessment, and to the right, how they are covered by different kind of game scores. Yeah, And we want to investigate it in more detail in a more or less large national project called Multimodal, which is managed by my colleague Silvia Ruseger and me. It's a test region in Styria. And it's about, originally it was thought to be 1.5 years, having a neuropsychological test battery at the end, at the beginning and the intermediate stages, and also investigating the risk factors, the lifestyle parameters over time, applying the Playful training with Digital Life app, and then doing AI-based data analysis. So under the pandemics now, originally it was thought they have 220 patients involved, so maybe we will scale down, or at least for the moment, to 30 interventions, 30 control, person with dementia, Alzheimer type, and basically also apply functional magnetic resonance investigation, whether it's really Alzheimer diagnosis, pre-post analysis, how it develops. And we want to investigate the risk factors, the modifiable risk factors, as we have seen at the beginning. There's early work from Norton and others that quantifies the impact of physical inactivity and so on. And there's other work, and as you can see here, we're applying a checklist. It's called Fantastic, and our variation is called Fantastic D for dementia, by Wilson and others, brought up, validated positively, and that should reflect actually these lifestyle factors like social isolation, physical activity or inactivity, obesity, or applying good diets, if you smoke or not, and so on and so forth. So this is the kind of spectrum, the list of risk and lifestyle factors that impact the probability to get dementia, or to make dementia, to worsen dementia if it's already running. So to the right, you see the different kind of question categories in the Fantastic and the Fantastic D checklist. On family, like the social embodiment, so to say, the activity, the physical one, the nutrition, and so on and so forth. And here you see how it's implemented in the app. So you can like tick different kind of values of the parameters, how, for example, active people were physically during the last weeks or the last months. Then the next one is about smoking, about how you behave, if you're depressed, your nutrition, your sleeping quality, and so on and so forth. And in the end, we want to refine, of course, this kind of cognitive assessment, as we have seen before, and provide a kind of estimator for continuous estimation of the cognitive state, the global level, like the overall MOCA score of the person with dementia, looking into the black box, and also into the functional specific cognitive impairments, and also see the interaction between the variables, like how various lifestyle parameters kind of interact or have an impact on different kind of cognitive impairments. And in the end, these kind of numbers and the course over time should provide insight for the person with dementia themselves, also the informal and the formal caregivers, the whole care staff. And we want also to apply predictive analytics, prediction of the MOCA, the subscore, as a kind of functionality to have an alert for intervention in times, an early alert of a possible rapid decline, because we know it can happen in 1-2 months that the MOCA score goes down 10 points or something like that. That can happen, and if you care maybe in time, then it will decline on a much larger time scale. And the future aspects are, of course, to identify in detail the specific functional impairments, and then also apply kind of a recommender in terms of a personalization to focus the training on specific functional impairments. And that should be, in theory, much more efficient than how it's done currently. And in the project, we have scores from different questionnaires as data, as ground truth data, the cognitive assessment, the MOCA, care dependency scale, geriatric depression scale, apathy evaluation scale, and so on and so forth. The MR analytic results, blood analysis as well. And on the other hand, we have the scores from the digital serious games, from the Playful training, but also for eye tracking features and semantic gaze interaction from the Myra game. We have the parameters from the lifestyle checklist score. And of course, we want to find out correlation using nonlinear regression and applying for predictive analytics, long short-term memory networks, decision trees, and so on, standard statistical ARIMA estimators, and want to look into more detail. And this work with the tablet PC is embedded in other activities that are highly related. So for example, bottom to the left, social robotics, there's a work applying the Pepper, the social robot, to motivate the person particularly to adhere to their training. And we've seen high adherence to the training in this kind of field tests, and also very much accepted the social robot, and it's very specific set up to have a companion and a coach kind of function of the social robot that we have developed. And also augmented reality, the social robot you can see in the third demo in the afternoon, the augmented reality cognitive training you can see in the fourth demo, and bottom right you can see the relation to mindfulness, developments for interventions based on mindfulness ideas. You can see that in the fifth demo, and all these kind of ideas and developments should be related to support a person with dementia, the informal and the formal caregivers, for prevention and intervention. So just to wrap up, we have seen that early stage dementia has diversity of cognitive disruption, and this kind of one-size-fits-all stimulation might be unlikely to be the most useful approach. Therefore, we give merit to a more fine-grained assessment, and we want to go this route for AI-enabled decision support. And these kind of technologies should inform which aspects of cognitive performance could be targeted through the training towards a much more personalized training using these AI-enabled diagnostics. And the thanks now go to, of course, the end user, the person with dementia, the trainers who provided a lot of input, enriched the projects, and without them, all the developments were not possible. Also, many thanks to all the contributors to the different kind of projects. And also, I would like to thank the funding organization, and thank you for your attention.